So thank you for the introduction, Jersey. I am an entrepreneur at heart, and I have a yes problem. So whenever there's a shiny new object or a way to make money, I'm typically going to say yes to it, even when I shouldn't. And a lot of what I learned came from that, get myself into a little bit more than I probably should have gotten myself into. So about 5 years ago, a contractor that I do a lot of work for called me and asked me to come by their office and look at a project with them. It was remove and replace phase one of the 120-year-old wall that protects downtown Charleston. And we sat down, looked at drawings, and looked at them, reviewed them. It had about 20% of the project was FRP at the time. And I said I'd get back with them, went outside in my car, got my phone out and Googled what FRP was. And after looking at it for a little while, we decided we'd bid it. And we went through a process of elimination. Now, what are the pros for the project? Pros will be a limited competition. There will be a lot of good publicity, hopefully. A con would be that it could be really bad publicity as well if it doesn't go well. And not all projects go well. So what do you do to make sure a project goes well? Well, you plan. And we planned a lot. This is what we learned. We've done phase 1 and 2 are complete, and we're about 95% complete with phase 3, and we'll be more than likely doing phase 4 later this year. So this picture is the old battery wall. When the water wasn't coming from underneath it or through it, it did a really good job of going over the top of it. Something interesting we learned about the wall is phase 1 had no reinforcing in it. The original phase 1 did. And so when we took it out, it actually had evidence of holding up better than the later phases that had reinforcing in it. Black steel reinforcing was causing damage to the extent that, the piece would just crumble when you went to cut it out. So what we learned is that in 2018 and 2019, the only information we could find is that FRP was expensive. And anything beyond that, any kind of questions we asked, we were kind of looked at like we were asking questions about aliens or Yetis or something. Our installer that we typically use to install black steel for us just said, I have no interest in it, you're on your own. So we used a solid pre-construction technique called a WAG and put our wild ass guess to it and priced it, and here we are. So we knew where to get a piece of black steel. We didn't know where you could get FRP. We knew you could bend black steel. We didn't know how you bend FRP to the conversation earlier. To begin with, it was more expensive, but as production has increased and steel prices have gotten higher, in some cases it's a dollar for dollar exchange. The manufacturing is a lot different. It's extruded, molded, and once the material is cured, it is set, and modification beyond cutting is almost impossible. So this required us to dig really deep into the shop drawings to make sure there are no conflicts. Bands, shapes, certain different sizes take longer to make. So we couldn't find out we had a conflict in the field. Manufacturing FRP takes weeks, molding shapes takes months. And then it came to the never-ending problem with shortages. Rebar shortages on job sites are very common. So not enough hooks, not enough hairpins. How do you get in front of that? So what we did is we created our 911 bundles, our breaking case of, bundles of rebar or FRP that were at our office. And so if we had a shortage, we knew we had extra parts and pieces to go get and open up. And that helped us stay in front of any kind of 911 problems we had. The material's about 4 times lighter, which means you can actually put more FRP on a truck than the truck will hold. Which is really great on tight job sites where you have to shut down projects to get trucks in, pull the truck in, and unload it. You don't need to unload it by a forklift or by crane. 2 guys and a little bit of time will unload it on their own. It's very light, it's very easy to handle. I really want to touch on bending. These 2 pictures right here are benders you can buy on Amazon or nearly any construction supply shop there is. And so if you need a piece of bar, you pull out a piece of black steel and bend it. If you need 500, you call your fabricator and they'll bend it. They have benders that'll bend thousands of bars at the push of a button. As contractors, we have leaned on the reinforcing steel suppliers to make up for bad plans, bad submittals, bad drawings, bad shop drawings, and a general lack of planning. If you do this with FRP, it will burn you. My nightmare scenario that kept me up at night was a possibility that we could have the wall that protected Charleston, albeit badly, demolished, and not have the necessary FRP to replace it as a hurricane came our way. Like I said, not all publicity is good. Production of shapes, as the technologies move forward, I hope to one day the bending of FRP can be closer to the process of steel, but right now it's molded, and it's very important because, as you can imagine, molding is not as fast as steel. In this picture, you have the same shape and size over and over and over as far as you can see, and it's easily manufactured due to the repetitive nature. A lot of projects are not like this, and FRP has a disadvantage. When you have a different shape, you have to have a different mold, and so it just takes a lot longer. And unfortunately, none of us are perfect. Some of the drawings, they change sometimes. We have problems, we mess up, we make mistakes, and when you do that, you have to react. When that happens, the quick reaction necessary to keep the project going is usually going to make you use either a black steel, stainless, epoxy coated, something along those lines if you can't wait and shut down the job, for lack of better words. Black steel typically comes from a manufacturer with a fabrication shop or a fabrication shop who buys from the manufacturer. They bid the job, they detail the job, they bend it, they ship it. It's a setup the FRP manufacturers are not used to. They make FRP, they sell FRP. Anything between those two steps, they didn't know what was going to happen. So our greatest success came from partnering a steel fabricator with an FRP manufacturer. The shop, the fabricator brought the service, the bending, the details, the estimating side of it, and supplied that to the manufacturer of the product, and we got the service that we're usually used to. An example of that is we had a manufacturer trying to cut bars to length to ship to the job site, one at a time by hand, and their facility is nearly 100% automated. So they were taking weeks to cut bars. The fabricator knew that you can bundle it all up and take a quickie saw and cut the whole thing off. And so they could cut a bundle of FRP in an hour, not weeks. And so that partnering made a steep learning curve very easy to overcome at the long term of it. On the topic of cutting, an FRP splinter is not fun. They are very sharp, they are hard to see, and they will go through typical nitrile cut 1, cut 2 level gloves. You need heavy leather gloves to protect your hands. Differing manufacturers' products act differently. Some are more friendly than others. Some are much more prickly and splinter a lot easier than others. You can cut it with typical abrasive blades, circular saw, sawzall, hacksaw, just about any way you can cut black steel, you can cut FRP. A metal blade, like a Metabo metal blade made for cutting black steel, will hold up really well to cutting FRP. It's very quick, clean cut, and it will not fragment. Long sleeve shirts, glasses, face shields, recommended for cutting FRP. In the field, the shapes and sizes come into play because of the size, the supply concern, and because of the differing shapes, you might have some congestion issues. So you may not be able to bend, quote bend, or mold your FRP in the same manner you do black steel. So you may end up with 2 to 3 places or pieces of FRP to replace 1 piece of black steel. So when you do this, you can have some congestion issues. You may have a concrete crew that shows up wondering where to put the concrete. So you gotta have a plan, SEC, small rock, smaller head vibrators to place your concrete. You make sure you go over that with your engineering team, your placement crew, and your ready-mix company to make sure you're all on the same page. It's also necessary to get it out there early, but it degrades in sunlight after about 4 months. So if you get it out too early on the job site, it will cause some issues if you don't protect it or don't have a way to limit that exposure. Once you make all that, have all the planning and get the product on the job site is really where the results start to shine. So it's lighter, looks a little bit different, but otherwise it installs just like black steel. And once you grab a hold of it, be prepared for some really amazing results. The crews put it in, love it. This material is a quarter of the weight. Morale went up a lot because they're not burning their hands because it's not black, and it's heavy, it's not heavy anymore. And so the lower weight made pre-time possible when it wouldn't have been possible due to the limited access on the job site. Carrying a grade beam by forklift now becomes carrying a grade beam by hand. And this video you can watch is some guys carrying a 30-foot mat. It's 30 feet long and 14 foot wide, and they just carry it in place by hand. And if this is black steel, you would never be able to do this. These two slides are very similar to that. It's carrying pieces of sections of FRP that we pre-tied into place. This is a piece of a wall beam, and we're just walking it into place. And this is a piece of gray beam. And walking it into place. This picture was taken on a Wednesday morning at 7 a.m. It's about 110 feet or so of old existing wall cut and ready to be taken down. This picture was taken 34 hours later. 110 feet, formed, tied, inspected. We poured it the next morning. I went out to tell them how great of a job they were doing. And my foreman on the job said, man, we left a lot of time on the table. And I said, what in the world are you talking about? And he said, we could have done it faster. We should have poured it today. And it's really interesting because the lightweight material made it almost like a game for some of them to see how fast they can do it, because they're just having fun. They're just having fun doing work that used to not be so much fun, just throwing it into place. And this is the final result. So the picture on the left-hand side is the low battery wall phase 2, standing on it, looking down towards 1. The picture on the right-hand side is the termination point of phase 1. Phase 1 and phase 2 are both about 900 feet long. Phase 3, is 1,800 feet long, and we did phase 3 in the time it took to do phase 2. So it's twice as long, and we did it in half the time. So where we're trying to take FRP, as you have figured out, I like it a whole lot right now. And so this is what we're trying to do with it. As the pandemic hit, prices kind of got crazy, and some supply issues popped up where specific wire meshes and especially heavy gauge steels weren't available anymore. So it presented us with an interesting opportunity to value engineer some projects with some ability to hold teams hostage. If you want to build the project, you're going to have to change the product you've used. So some originally rigid engineers were now very open to suggestion, and so we were able to bring in manufacturer engineers and change some stuff out. This picture is a job that we were the design build contractor on. This is a matte foundation. It was originally drawn as steel. We changed it over to FRP because of access issues. So instead of hand-toting 60 tons of black steel in, we hand-toted the FRP equivalent. You can see the black steel coming out of the wall for the wall dowels and for column dowels. Charleston is a seismic zone, so we had to use black everywhere else. But you can imagine how much easier it was to carry that in. As wire mesh prices and steel prices have settled in to where they're at right now, it's almost a dollar for dollar exchange with FRP, depending on the application. Anywhere you have a high likelihood of exposure, I suggest looking at it. And if you're trying to make the change, find an engineer or a manufacturer who's familiar with the product and the codes. This is a picture of where wire mesh was originally designed. It was at a stadium, and there was a tennis tournament coming no matter what, so the wire mesh wasn't available. We changed it over to FRP. The manufacturer had set up to bring a film crew in because it was a big deal, it was a big project. And the film crew showed up that morning, and we weren't over there tying FRP yet. It wasn't ready. So the superintendent drove over to the yard, threw his bundle of FRP on the back of a truck, drove it over, and unloaded it himself. No equipment, just him. And so that was really all the promotional filming they needed to do. They were done after that. And it's just really, really fast. For all you engineers out there who specify wire mesh, the picture on the left is an example of what it's doing, holding down the vapor barrier. It is never where it's supposed to be. If you walk on it, step on it, put a laser screed on it, pour concrete on it, which is supposed to be designed for, it's going to end up on the bottom. The picture on the right is a concrete truck driving over the top of some FRP. If you notice right here, this chair, right beside the tire, is where it's supposed to be. The FRP is where it's supposed to be. It's deflected just a little bit behind it, but right on the other side of it, it's back right where it's supposed to be. It's a very durable, very strong product. You can drive right across the top of it, and it pops right back into place. This job was originally designed to be a heavy gauge wire mesh. If you've ever flown wire mesh onto a slab on metal deck with a crane, you know it's a very precarious operation at best. It's not easily wielded, it's heavy, it's flexible, it moves really weirdly. So we changed it to FRP, primarily because we like it, and secondly because we could make that, force the issue. In doing that, you can hand it up by hand if you really want to. You can fly it up with a forklift and just unload it by hand. It's very easy to handle. If you're interested in using FRP, the first thing I would recommend you do is find a friend, a partner, manufacturer, engineer, contractor who knows the product. Over the 3 phases of the low battery wall, it went from about 20% FRP, 30% to 100% at the 3rd phase, all FRP. And the reason that was because the engineers weren't comfortable with the FRP. We weren't comfortable with it. No one was comfortable with it. And so as we got better information and better partners, everybody was a lot more open to using it. The FRP manufacturers will come to you. They'll do lunch and learns. They'll help engineers. They will help you change a product or project over to their product if feasible. And I have some high aspirations for FRP. As long as black steel oxidizes, it's here to stay. Conventional black steel fabricators, they have the best existing tools for the management of FRP. They already have the estimators, detailers, project managers, and are versed in the management of steel reinforcing. And so that crosses over very well to FRP. And the early adopters of this process and fabrication of FRP and manufacturing FRP management with manufacturers are going to have some flexibility and advantage over people who don't. And so if like an executive at a very large manufacturer had the opportunity to partner with somebody several years ago and he said, we make black steel. And now he's at a disadvantage because his black steel rust. And and the guys who he was kind of shunning, they're at an advantage now. As FRP has moved forward and advanced, the molding capabilities have gotten much better. Shapes they couldn't mold originally can now be molded. The timing, how fast they can do it, is much faster. I do know that there are some manufacturers working on being able to stop the curing process and almost having green bars set to the side for a 911 call. So if you need that quick bend or a way to fix a shortage or a change, you can do that. I have a lot of aspirations for FRP in that we do all aspects of concrete. We do walls, decks, tilt, you name it, we do it. And so I think that one day, hopefully, we will be able to fly pre-tie wall and column steel to a deck with cranes, set it down, and then a man can go over there and pick that up and walk it into place instead of having to fly each column cage or pre-tied wall cage into place. And I think there will be some really great opportunities to capture that. I voiced some of these things to an FRP manufacturer executive and a friend, and he told me it wasn't going to happen. And then he politely changed the conversation to a new topic of coatings. And I wasn't going to put this on here originally, but I think it's a great example of the ever-changing product that FRP is. We were talking about splinters and sun exposure earlier, and he told me that by sometime mid this year, their product will be coated, and it will protect it from UV rays and prevent splintering. It made me laugh. And over the last 4 years, we've had the pleasure of getting installed a lot of FRP. And as we've done that, we've noticed it's all changing for the good. More shapes, more sizes, more rapid responses, more manufacturing lines, closer manufacturing lines, better management, more experience. And I pointed it out to him. And I told him that the product isn't limited and that he's limiting the product and to get back to the lab. And he laughed and I said, hey man, I've got a yes problem. So my last 4 years of working with FRP has been very exciting, and I'm very excited to see what it's going to do for us. And if you have any questions, feel free to ask.
Hi, good presentation.
Thank you.
Contractor's perspective is always important. I saw your slide where you used FRP for deck instead of wire mesh. Did you see any performance difference between regular black steel versus FRP from the cracking point of view?
So it will, since it's modulus, is not as stiff, it will allow for a little bit more cracking. You can offset that with a little bit more FRP. So like for example, if a black steel deck is say number 3 is at 18, you may have to take the same number 3 to maybe 12 inches to offset that and have a little bit more FRP.
Have you done that, and has that changed the cracking pattern?
You know, I think the only thing that I guarantee my concrete is going to do is crack. So,
Well, that keeps me in business, though.
yeah, exactly. It keeps me in business too. I do crack repair. So, I think the other side of that is the expectation is for it to crack. It's just about what the application is. And so, slab on metal deck, you know, we expect it to crack, and they're going to cover it with something typically. And so, if it's going to be a exposed polished floor, something along those lines, we usually look at it a little differently. And so that deck specifically was polished, and so that's why we used FRP in lieu of putting fiber in the concrete, because you could go with a heavy dosage of fiber and do the same thing, but the polishing aspect of it will expose all those fibers and have some aesthetical issues. So FRP went on a closer, you know, spacing, and it worked.
Thank you.
David Lang from University of Illinois. I was real intrigued by the rig you set up with kind of a furnace for field bending. And help me know if I understood that right. Because it seemed to me that you were basically saying, we've kind of done it. We know how to bend bars in the field.
Black bar, black steel.
Is that what that was not FRP?
No, that was not FRP. And that was my point, is that FRP, you can't do that. But nearly every
I
concrete
misinterpreted
contractor I've
that.
got, or I have, and every crew I have has a bender in their trailer.
Okay.
So, like, you just run out there and bend a piece of steel if you need it. And FRP, if you
I never
think
saw
you're-
the furnace thing. I thought that was always
No,
a
it's
cold,
it's an
cold
electric
bend.
automatic bender.
Huh?
Yeah, it's an electric automatic bender.
Okay.
But if you do that with FRP, you're gonna have problems.
Okay, very good. Thank you.
All right, thank you.